Hey guys, what's up? And today I'm going to take you on my journey as we go through modifying the Nerf Ultra 2. So if you're interested in that, stick around. Also, fair warning, there's probably going to be some self-shilling because I just designed some parts for this blaster, so if that sort of thing upsets you, don't watch the video, I guess. But the first part I came up with was the under rail. Now I made both ultra dart holders and normal dart holders, and that just sort of slides on under here, holds extra ammo. So that'll be helpful for what we're doing today, and then I'm also working on some other parts. I don't know if they'll be ready for the video yet or not, but I just wanted to mention that there's some shilling involved. So the Ultra 2 might be the first viable Ultra blaster that's come out. The Ultra 1 was sort of a dumpster fire between the price point, the first blaster to use a proprietary ammo type, and it just kind of being bad in general. Didn't really lend to a great start for the Ultra line. However, the Ultra 2 appears to be a bit better. So now that myself and a bunch of other people have been starting to get it, and some people have even started to make aftermarket parts for it already, which is cool. I've seen a few conversion mods to take the blaster and go from shooting these weird styrofoam packing peanut darts that they come with to shooting a normal size dart, which is kind of cool. But I want to keep it as an ultra blaster, surprisingly enough, for this mod, because right now we're testing in our local games. We have some class modifiers, like melee only classes, that have to be taken out with certain darts. Now the ultra darts we are testing as being one of the alternative ammo types that you can use to take out these special zombies. So with this being a 6-round pistol, this might be actually good for that purpose. So while many other people have been converting it in this mod guide, I am going to stick with the ultra darts. So once you open up the blaster, I just cut the leads real quick so that I can butterfly open the shell without having to keep the two halves together, because we're going to rewire it anyway, so it doesn't really matter. But you can see the majority of the internals are all within this little tiny area. You got the two flywheels that may or may not be offset. We can go over that a little bit later. Got the turret, there's a trigger and a firing mech, which I just took out. But the first thing you're going to want to remove is a little piece up here that looks like this, and there's a little spring that goes along with that, and that just allows you to freely pull the trigger mechanism, and it allows you to also shoot different types of ammo if you really wanted to. This piece just sort of catches on the fin and then detects if it's an ultra dart, I guess. So if it's not in the right type of dart, it won't even let you pull the trigger, which is kind of lame. So we're just going to remove that and give it a bit better of an action. The next step I'm going to do is remove the trigger and rev trigger, which normally go in here and in here, and the rev trigger pushes this little tiny switch, which in turn allows the circuit to be completed as long as the jam door one is also closed. When you have the normal batteries in, but that's kind of lame, we're going to switch it to LiPo. And in order to do that, a LiPo would totally fry this little tiny switch and the little tiny wires that go with it. So you have two options. The first option is a bit more traditional. You're going to take a larger amp switch. This is a 21 amp switch that's quite popular, and a lot of vendors sell this guy that supplies stuff for modding. It's quite popular in the community, and what you would do is just drill out this area and sand it down, maybe clip out some of these supports, and then you're just going to want to fit that guy in, so that way when your rev trigger is pushed back, it activates this guy, and it makes a nice satisfying click. However, I think for this guide, I'm going to go with the second option, which is using a Mosfet board, which essentially allows you to keep in the stock switch, because this one's a little tight, to be honest. You know, you'd have to clean out a lot of these ribbing and other support type stuff and remove that and put in some like hot glue or epoxy putty to build up a small area to put in that new switch. So what I'm going to do is I'm just going to keep the stock switch and even the stock wiring. I'm going to trim it back here somewhere, and then I'm going to rewire it to here, and basically that just acts as, instead of a larger mechanical switch like that 21 amp one, this will allow it to do it electronically. And as you can see, this is, I'm going to butcher the name pretty bad, but I'll link it in the description. It's Sould, or it's like solid, but with a U. But anyway, I'll link that in the description, and I'm going to test out this board which is a Mosfet board by him, and basically you just solder on the 2 wires to that, your 2 flywheel motors, and your battery, and then you should be good to go. So I'll go over this a little more as we get to that step in the guide. I just wanted to let you know that there are multiple options available. I forgot to mention this earlier, however, what I normally like to do is take pictures as I disassemble the blaster, so that way I have a reference point for where all the pieces go when I put it back together later on. Just to go over some of the tools I'm going to use real quick, I have the soldering iron. You could use a really cheap one. I had a Radio Shack one that I bought like years ago up until recently, however it finally crapped out, so I bought a slightly nicer one. I got some lead-free solder over in the corner. Then I got a third arm tool, or helping hand tool, whatever you want to call it. This just has this little flexible guys, which you can use to hold on to parts, which is really nice for not burning your hands. I have a little exhaust thing with a filter in it, so it pulls the air away from the soldering. Like I mentioned, I'm using lead-free solder anyway, so it's just really to get the smoke out of there. But it also does have a filter. Those are also pretty cheap, or you can make them very cheap, so I would definitely recommend doing that. Then I got a wire stripper and some cutters, which are off the screen. You could also just use the X-Acto knife, which I end up using sometimes for some of the smaller wires, but this is good. Little tool to have. It just strips the ends, and it works, like I said, better for the larger wires. In terms of supplies I'm going to be using for the mod, I have a little 9.5 graphene battery. I would recommend buying the Out of Darts one, which he had, I believe, custom made, and it comes with an XT60 connector already, so you don't have to do a ghetto job soldering a XT60 connector to a smaller battery like that. The live circuit, or the high amp circuit, whatever you want to call it, is going to be using this larger diameter silicone wire, and I'm, like I said, going to be using XT60 connector. Then for the switch, since I'm going to be keeping the stock one, I'm just going to use this Mosfet board that I brought up before. It has a thing included with it for also using a kill switch if I wanted to do that, but I think instead of using that I'm going to opt to use this little jumper cable instead, because I don't really feel like putting on a kill switch, because it's likely something I'll forget to turn on and then end up getting killed. So as this is going to just be a ditch effort sort of pistol thing, I think I'm going to forgo the kill switch and just use the jumper for one of the switches, and then the second one will be that, which will activate the blaster. So I'm going to take out this cylinder over here, take out the cage real quick, and then I'm going to be removing a lot of this later, but for right now, there are these 2 leads off of the existing switch. I'm going to cut those and leave them as long as possible, and then I'll figure out where I'm going to seat everything later. But for now, I'm just going to cut this out and then remove this board from the back of the motors. Okay, so we got a couple things going on here. I removed the board that you saw previously on the back by just breaking it off with some needle nose pliers, and then I heated up the little solder joints here just to remove the little segments that got stuck around those, and then they just pulled right off once the solder was warmed up, so that was pretty easy. Now you may also notice on the cage there's positive and negative leads already marked. So normally I would just do positive as one row and negative as the second row because I set the motors up. However, because they are set up this way from the factory and I'm not replacing them, I'm just going to follow the positive and negative and assume that that is correct. You also notice I made a guide for the flywheel cage with some 3/4 inch PVC and then a little stubble worker barrel. Put E-tape around both of those and then glued them into place. So now as the dart goes through the flywheel cage, that will help guide it, and then it won't veer off. It'll hopefully correct it as it flies out. I might actually end up trimming that back after some testing, but I'll keep it like about an inch for now and then see how it goes. I noticed that the Ultra 2 had some accuracy problems from some potentially misaligned flywheels when I was playing around with it, so maybe this will help it out a bit and control the dart as it exits. So I don't know how this happens, but if you follow the positive negative that's on the motor cage, one wheel spins one way, one wheel spins the other way. So much as expected, if you trust Hasbro for 3 seconds, your blaster won't work the right way. So I did positive in the back, negative in the front. for this one, and now it's spinning the correct direction. And then I just wanted to say that the wiring with one of these boards is incredibly easy. I know a couple different people make variants that are like this, but basically you just take your positive and negative lead, one from the motors, doesn't really matter which one, goes into a positive and negative terminal on the back of the board, as you can see right here, and then one set for the battery, which I just wired an XT60 to. And then you need one for your switch, and then you are good to go. So I'll fire this guy up real quick. It's kind of loud, so fair warning. But when your switch connects, so I trimmed out the battery tray a little bit. I removed the plastic along this edge down here, and then I trimmed out the back of the second row of the AA's back here, so I can run my wire through. I can see the board if for whatever reason I need to, and then also it gives me a little extra space to tuck in the wire from the battery. The battery mentioned earlier is pretty snug in here, but it does fit pretty well, so I don't need to 3D print an extended tray or anything. I should just be able to put it in and be good to go. So I'm going to give it one more test, and then I'm going to close up the shell. I'm going to do a quick chronograph test with both a 2S that I actually used it with during an event and a 3S just to see if we get a reasonable performance boost or if it's just going to break the darts. With the exceptions of the errors, we got a high of 93, a low of 80, and an average of 85 feet per second. So for that string, we had a high of 113, a low of 62, and an average of 97. Now if we go back to the last one, which was kind of a dud, and we delete just the outlier, then we get a high of 113, a low of 82, and an average of 104, so it doesn't affect it too much. So final thoughts on the blaster: I would probably modify it to shoot half-length darts rather than just modifying it to keep the ultra darts, because I used this at a local war where the ultra darts we were testing, counting them like megas and other special types of ammunition where you could take out special classes and modifiers as opposed to like normal darts. However, I felt that this blaster fell in a weird category where it was too big and bulky between the length and just how wide the shell is, that you can't really carry it as an effective sidearm. It's just pretty bulky and awkward to carry, but it's also not good enough to be a primary blaster, so it falls in a weird sort of middle ground where it doesn't really have a place, in my opinion. Another thing I found is that even with modding, this blaster is still kind of prone to jamming. One thing that happens is when it's held in the upright position and potentially, like I said, on your thigh or in a holster or something like that if you have a really big one, the bottom dart that doesn't have a stop at the back of the cylinder tends to fall down a little bit sometimes, and it can fall into the flywheels. So when you go to rev it, it just jams up instantaneously. Or the darts, even with the guide I put in, it seemed to help a little bit, but they still kind of flop around and can get caught in a wind. So overall, I think the Ultra ammo type just isn't that great. As mentioned earlier, I did end up 3D printing my own part, which you can grab on my Etsy store if you're interested. I also made this to hold normal darts, so if you get a conversion kit, you can still use this. It's a little bit shorter. It looks like that for comparison, although I might have to make a 9-dart version now because people switched it from a 6-dart cylinder to now there are 9-dart cylinders available, so maybe I'll have to look into that as well. As always, guys, thank you for watching. I hope you enjoyed, and I will see you in another video.